Let's at least look at your lab first before we start looking at code. Hey, look, I'm going to ask you to code it. Hope no one is surprised by that. Anyone? Bueller?
Heart is broken.
Oh, I know.
I'm
I was waiting for someone to say I'd be disappointed if you didn't.
I would not be disappointed.
You would not be disappointed? Really? Really? Oh, you moved me, yes.
Why do we have 2 template values?
That's what I was going to ask y'all. Man, that's beautiful. Why do we have 2 template values? Because the key and the value may not be the same type.
Wow.
Whoa.
Okay.
It sounds like when Peter explained Family Guy.
Wow.
All right, so you have class K. Hey, what do you think that represents?
Key.
Man, y'all doing great. And V is the value.
Vegetable.
Vegetable. Nice, thanks. Good job, good job.
That came from the back.
Came from the back.
Back of the garden.
All right, let's go ahead and actually start doing some of this in class. I bet y'all like that idea. Lab 18. What do we have in here? Oh, good. Little source, hashtable.hpp. Oh, wow. I already have some code for you. Man,
Oh, thank you. You are too kind.
we're not doing it this way. Haha.
It's all gone.
It's gone.
Be gone.
All right. So, if you didn't see that in the past 5 or 10 seconds, what's a hash table?
It's a key value pair.
All right, but what we're doing hash tables with chaining, so what is the data structure? A linked list, okay, we'll start with a linked list. Hold on. An array of linked lists, but we probably want to use the STL, so instead of a linked list, we'll use a...
Oh no. Link list.
No, we are going to use the STL. But yeah, forget. Yeah, let me give you all a hint. Don't use your old code, just use the STL.
Yes. What if I like my old vectors and lists?
I'm glad you do.
It's just a vector list.
Vector of list, there, you got it. All right, guys, let me help you out. If you ever do this, it's going to cause sadness.
Okay.
But let me first, well, it's a vector of lists, and that list is a linked list of values and keys, which, yeah, so we have to have a node. All right, so we can use a node, or we can just use the STL's pair function.
Oh, nice.
Okay, and hey, look at that. So we're going to in the pair, in the list, in the vector, and we'll call it mtable. All right. Now I'm going to try and compile this, and it's going to fail miserably.
Okay.
Pair was not declared in the scope. Oh, that's because I talked to. Okay, hold on a second. Oh, did I actually commit the? Oh, wow.
So now the code's
Yeah, you'll have this code up on the GitHubs, but that's all right. Wow, I totally forgot to clean this all up. Man, that was lame of me. Well, Merry Christmas. Hey, compiled. Wow, they fixed it. All right, it used to be that this made no sense and would cause a compilation error, but I'm so glad they fixed that. Well, actually, you know what? They may not have, because I forgot to actually. No, it's in there. Great. So it works. Okay, they fixed it. I love it when they fix things. That used to be a huge error because the double greater than sign meant downshift, and then the parser would mess up. But it looks like they fixed it, so that's great.
So no sadness did not occur?
So sadness did not occur. Hash free. Okay, so first function, initialize the hash table with size. Okay. Destruct everything. Return true if successful. Okay, so bool insert, return true if successful, aka it is unique, otherwise return false. So it's gonna be a little different than the slides. If I give you a key and you find it in there, don't override it, just return false.
So he's already gonna find the linked list, or the list.
Yeah, return false. Get out, return false. Other implementations would override it. This one, I want to make sure you actually write it yourself. You probably should write a print function just to help you out. Let's see, remove the value associated with the key. No, why don't we need a value for this one?
Because once you have the key, since there's only one thing there, you can just go there.
Yeah, there's only, everything's done by the key. It's unique, yeah. You don't care what the value is. And then the last one retrieves the v val that the key maps to. Okay. Okay.
So you put the key in the brackets. Yeah.
Yes. Oh, yeah. Yes. Yeah. The key goes in the back brackets, right? Okay. And this is where it gets a little weird. So with your hash code, you need to actually manually write out the functions for key and for string. And I'm just telling you I'm only going to use keys that are integers and strings for now. But this is actually part of your grade because you'll have to figure out how to write those functions. Let's go. All right. Yeah. Okay, so if we have a size, wow, look at that. I even wrote that for you. Have y'all seen this syntax before? Nope. All right. So, here's the issue. Let's pretend this didn't exist. And instead, we just have this guy. But we want to initialize the size of the vector, aka mtable, right? Well, normally you'd want to do mtable dot set capacity or something. What was that? Let's go look this guy up. Let's do vector C++. Sounds great. All right, we'll use this website, which always takes longer to load than you would expect. Do we have a set capacity or capacity iterators? What's that? Resize. Okay, so we could use resize and try and resize it, but we may not get
There's also
reserve, request a change in capacity, so we could try reserve as well. Request the vector capacity be at least as long as n elements. And okay, so we could do reserve size. That'll probably still work. Yeah, it still works. Let me just make sure we, oops, make and test hash. All right, cool. All right, we could do that. Now, but if you keep this in, if you think about what's going on, the vector's constructor is already being called, so it's already allocating probably some memory for itself, and then you're asking for it to resize again, which is not a very efficient way to go about it. What you want to do is try and call the vector's constructor. The problem is, since the vector is part of the object itself, because notice back here, you have the vector. Is it a pointer? No, so it's part of the object itself.
It's created before the constructor is.
Right, it's created before the constructor is. So if you want to use that guy's constructor, you have to use a very special syntax to C++, which is essentially this guy up here, and you're using the, I think it's called the initializer list, if I recall correctly, and this is how you actually call the constructor for that class. Notice that you, even though you're passing in size, you can pass it to mtable. And now call mtable or vectors constructor, passing in size, which is right over here. Let's see, size in, it's going to be this guy right here. Or actually down here. Yeah, size in, this guy right here. Because all the other ones have default values.
I like the address of this page. vector/vector/.
It's turtles all the way down. All right. All right. I haven't asked you very many memory questions, so let's see what this is. Is mtable on the heap or the stack, or is it static?
What's that?
Well, what if you create a pointered hash table and do a new hash table? Where would mtable be? Then be on the heap. So where is it? Thanks. There we go. It depends.
Well, I mean, in this particular case, it's something.
Yeah. Well, I asked a general question. Where is mtable?
Oh.
It depends on where a hash table is. If hash table's on the stack, then mtable's on the stack. If hash table's on the heap, mtable's on the heap. Yeah, it depends. That was the right answer. And if you figured out a way to stuff it in the static part of memory, then yeah, mtable would be part of static. Yeah.
And you deserve a medal.
What?
You deserve a medal if you did that.
Yeah. If you, ooh, I don't want to see the syntax for that. That would be ugly.
It's just like a file.
Ugh. Ugh.
Just thinking about it is making you cringe.
Yeah, let's not do that. All right, so we have insert, print, remove, and get. Well, I would ask which function you want to implement, but when it comes down to it, really we can't really test remove or the last one until we have inserts. So I guess we're writing insert. All right, so we have insert.
Don't we have to have the hash already working?
Do we have to have what?
The hash function already working?
Yeah, look at this. We got hash code passed in an integer. It returns a key. Okay, that's a good one. Kind of, sort of. We have a hash code from a string, and I return 0. That's probably not a good one. But look, you need to do something else. I'm letting you do it, not me. Not a problem, anytime. So, how do we insert something?
You gotta give it the pair. You gotta give it the pair to insert
Okay, well, okay.
the key value code. It needs a key value.
It needs a key value pair, right, if we're doing that.
Hash code the key, then go to that index of the vector and insert the key value pair at the beginning of the linked list at that position.
Okay. So we got index to get, so one, get the index to jump to the correct location in the table / array. Then what do we do?
Isn't it dot empty?
Dot what?
Dot empty? I know in Java it would be dot is empty. You do a conditional to check if it's empty.
Okay.
Doesn't the STL like list take care of
Yeah.
things?
So if you look here, we're not using pointers, which means that the M table is automatically initializing all the lists so that they're empty. They are a list. They're just empty right now. So I could, if I made these all pointers, we could go and hammer out all the code for it. But notice that by doing it this way, the STL is automatically initializing a lot of things for you, which is nice of it.
Always.
Always, yeah.
That's why it exists.
So like by default the lists are empty, right?
Yeah, the lists are empty, so we still need a pair. That's correct. So we'll go and do, we do need a pair of key comma value. We'll say to insert, and it has the key and the value.
Is it insert vendors like push product? I don't remember the.
Oh yeah, no, so it's a list. I don't remember what list had. Let's see. List C++. I don't think it had pushback or well, it might have pushback and push front. Let's find out.
Well, if it's a double linked list, then probably it's.
It should.
Yeah.
Good. It's got push.
In place front.
We'll do push front. To insert. All right. Okay. Are we done?
Man, we didn't just jump to it. We inserted it there.
Yeah, wasn't that push front? Jump to the correct location and insert. Insert. All right. I guess we'll just return true.
So do we
Let's see if it compiles.
check if there is already a
Hey, it works.
a value of that key?
Yeah, we didn't do that. Well, let's at least write a test case from integers to integers. So let's go table.insert. All right, give me a number. 58,
34.
34. Actually, let's make this easier. We'll just reflect the number.
34.
Yeah, there we go. Okay. All right, let's see if that causes any problems. Huh. Sure, it worked. Do we have any way to test this? Nope.
Yeah,
Well-
you have to implement the print function.
Well, implement the print function to see if we're doing it right. In order to write our test correctly, we'd have to implement the operator, but I want to leave that to you. So let's go up and implement the print function. Maybe I didn't even think about implementing the print function. Okay, well, let's go do that real quick. Alright, let's see if that compiles. It did, great. You probably should call it. Alright. So, how do we print?
I guess just for each index in the backup print the contents of the list.
What was, no, go ahead.
For each index of the backup print the contents of the list.
Okay, great. So, we'll do it the old way. What was it? mtable.size, I++. And then we'll have for int j equals 0, j is less than mtable sub I dot size, j++.
Oh, this is the worst thing ever.
Oh wait, we can't do it this way. Hmm?
There's a size linked list.
I thought we only had one element in each one.
Don't we have size? Yeah, we have size. But we have to actually use an iterator, that's the problem. Because there's no subscript on a list. So,
Yeah, so
for, oh boy. std list of std pair, this is where it gets weird. V iterator, thank you, 2 colons, iterator, we'll call it a list iterator, equals mtable sub I dot begin. Great. Li does not equal mtable table sub I dot end. Li plus plus. Great. And then we'll just do and then add a space, and let's go ahead and not forget to do an inline. Alright, let's see if your professor typed that correctly.
is there like an automatic printout for like iterator through pairs?
Right, so this is not going to work. That was a good catch. Let's see, what was our first error? Oh boy. Is a dependent scope. Did I misspell iterator? No. Li was not. Wait, was that the first error? That was. All right. Type. Oh. All right, C++. Fine. I have not figured out why it wants me to do this yet.
Is that just the thing that happens?
I did once because I had a problem which wouldn't let me do it otherwise.
Yeah, so it's like, all right, type name, we're done. All right, well, anyways, the next error
It's also the same thing.
is not part of, oh, actually, it's because we didn't include IOStream. And, okay, hold on.
And there's
Oh, no, there's more. Let's see if we can get to the top of the error novel. Oh my goodness. All right, error, conversion from to non-scalar type blah, 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 requested. All right, no matching for operator subscript with this. And what it's saying is it has no idea how to change this guy into this guy. Well, let's go see how we use a pair.
size. It does have size. List does have size.
Yeah, it does. But li is a list iterator. But we're using a pair object, part of the STL. So let's go load it up. And it should have a way to get the first element and the second element.
First.
Oh, there we go. Dot first.
So do you reference li dot first and then like a column versus li dot second?
So what's the first? The first is the key, but really we want the value. So we want the second.
Wait, do you just print out
We could print out the key. We probably want to print out the key right here, though. Maybe not. Well, actually, I know what you mean. I know what you're trying to say. Yeah, let's print out the key. We'll put in the little. All right. Now let's see what that does. Probably should make it first. Oh, there it goes. Oh, we're almost done. Conversion from, oh boy.
Doesn't look complicated.
No, it doesn't. It really doesn't. Conversion from allocator const iterator to non-scalar. Oh boy. All right, C++. Dot begin.
Oh, you need another parentheses. You need one more parentheses.
I need one more parenthesis.
Yeah, on the
No,
outside.
no, that's what you're trying to. No. That for loop ends over here. See? So I got that. What's saying is the type that this guy is not what this guy is, which is kind of odd. So let's do it this way. Dot begin sub I, because you're jumping to that list. You're getting that pair, and then you want that iterate. No, that should be fine. All right, error conversion from. Oh, we got to read this whole thing. List pair, aka list con int pair to pair iterator requested for type. Yeah. Now, why is that an error?
It says const maybe. It says
I hate
constant.
this. I hate
Oh, it's a
this.
const. That's why. So it wants it to be.
This is like start or something, right?
Yeah, hang on. I don't. Oh, this is gonna be ugly if it works. I don't think so.
But they have a constant error there, don't they?
Yeah, hold on. Is it before or after? I forgot what it is. Oh, it wants it before, I guess? Where did you put the word const in this one? That's going to be... Yeah, but you can't be const because you have to change it. So yeah, that's why it doesn't make any sense. Are we going to have to do this the hard way?
We converted from const iterator to a regular iterator requested.
Oh,
The one they did
here,
is-
it wants it to be const underscore iterator. That's what it looks like. Okay, sure. That's what it was. All right.
Oh, yeah, and it prints
Hey!
out. with
Yeah, it does print out a whole bunch.
lines.
So let's go ahead and clean that on up. Hey, that was fun.
Uh-huh.
Nope. All right, so let's go. Let's do if table sub I dot empty. And by empty, I mean totally not empty. Let's go to space. All right, and then it should just print out the ones we want. There we go. But we don't know what the key is, so let's go ahead and at least print that guy out. Or we should say, we'll say, we'll do subscript.
We don't know the key they got for each one.
Or the index is what I want.
Oh,
Yeah, we'll do it this way. And now when we print out, we know that index 34, you got that. Okay, great. Hey, that looks correct. Oh, good.
It seems like a terrible thing. It looks like you're using a lot more space than you're using.
Possibly. Well, here's the other problem. What if we insert 34 and then we put in 44?
Uh-huh.
So isn't that why you need to check if it is empty?
Yeah, we got to find out. Well, okay, hold on. But before that, what if we did 134 and then we did 431? I mean, that's fine, right? Ooh, we did a seg fault. Wow, we got another problem as well. We got all sorts of problems. Why is it seg faulting?
because because we returned the key, but the size of the table is 100 and 134 is greater than 99.
Right, so what do we need to do?
We need to modulus by the size.
Yep.
We need to pass in the size to the hash code. And
Well, or once you get it back from the hash code, you mod it by the size.
maybe,
This is the accepted way of doing it. You want the hash function to try and give you the biggest representation as an integer as possible, and then you just fix it later.
So for the integer, is this like the hash code function which is already there is acceptable in this lab?
That one is yes, but not the string one, of course.
Okay, so for the string, you just convert it to an integer, but you don't have to like have any like standards for like
It's got to have some sort of distribution that makes sense. That's what I'm grading it on. I'm not going to ask for the perfect uniform string distribution, just make sure you do something. All right, so now we'll modify the size. So now it should actually come up with something. Yeah, there we go. See, so at 34 we got 3 elements, but what's the problem?
2 of them was the same key.
Yeah. Oh man.
So we just have to do another check and return false if there is already a key.
Yeah.
If,
How do we do that?
if key already,
We
if contains
search
key
for it.
somewhere.
So we have to implement the operator with square brackets.
We need to search for the key, right? Luckily, we've already gone through the pain of figuring out what that looks like.
So can we just
It's a long code though.
implement the square brackets function and
That
We
is-
could try and do that too.
yeah,
Maybe
and
that's what we're doing here.
have a value which it will return if there's no
Okay.
such.
All right, there you go. I like that. Let's do. Well, this subkey, what is that going to return? Oh, here's the problem. It's returning a reference. Ooh. Yeah, you don't want to do that.
Wait.
It's returning a reference, which means it has to exist in order for this to return something. But if it doesn't exist, and that's what you're testing for, how would you test that it doesn't exist if it's returning something that has to exist?
Why are we returning the reference?
That made so much sense. It was so simple.
It was so simple.
Like,
Look, I have no idea
it
what you
can't
just
return-
said.
It can't return something that doesn't exist if it checks already for something that exists.
Yeah, but why do we return the reference instead of the value itself?
That's a great question. The answer is that if you return, you're returning the value, a reference to the value. That way you're allowed to change the value.
Oh, okay. So then you can like say hash like table square brackets key equals value. Okay.
Yeah, yeah, you can override it.
Okay, it makes sense now. So I guess we do have some repetition there.
Yep. Search for the key. 1, 2, 3, 4, 5, 6, 7, 8. All right. So mtable sub, this time just index. And we'll go ahead and do that over here. All right, and then what are we checking? If li dash first equals key, what happens?
Return false.
Return false. All right, let's see what happens now. Hey, it worked, I think. Yeah.
Yeah, it worked because the last one we added was 34, 44, and now we're doing that.
Okay, that's all I'm going to do. Any questions? Yes.
So to clarify, when you hit the link and we were talking about having, like, making sure you didn't have the same key, we were not making sure that the list was empty versus had one in it. We were just making sure in that list it did not have any duplicates.
Didn't have the same key, a duplicate
Yes.
key, yes. Now, due to our hash function, all keys should have the same location in the hash table. And then that way we just have to search that line first to see if there's no key. Yeah. All right, you're doing great. Any other questions? Comments?
So for example, if for the string hash table, would just converting the characters to integers and adding them up be enough?
Yes.
Okay. I guess maybe for a project, an idea would be to like, implement a more balanced.
Well, there's it gets complicated fast.
If we change the name and then change the image.
Change the name and change, yeah, if you change the name, you can change the integer. Although if you're just summing the digits, you could have 2 completely different names mapped to the same location. Let's see what else.
So as long as the automator doesn't happen to use these two names.
Well, it's not, that's not so much the, no. Even if they both map to the same location, the key is going to be different because the name is different.
Okay, I keep forgetting.
Yeah, remember,
but it's
you're
not
thinking
about-
a collision is, you're just resolving a collision through pairing. Like A collision is the problem you're thinking of. What I'm saying is there's no duplicate keys, right?
Yeah, so if the key is a string, then there's no need to convert the key to an integer other than for the index.
In order for finding the index, right?
So the only problem we could have is just having this slower than.
Right.
Well, you have the same name.
You have the same name, then you insert would fail if you tried to insert it twice. Right.
Yeah.
In this
have the same
implement.
names though.
Sure, that would be a limitation of this one, but we're sticking with it that way. Yeah, to answer your question, there's a lot of complicated hashing problems out there. And that's kind of what a cryptography is when you do hash functions. All right. Any other questions? Comments? Nope.
Just one. You mind uploading day 17?
All right, now we'll do that right after this. Thank you.
Okay.
Any others? All right. Well, you have this homework to get started on, and your project. How's the project coming?
Pretty good.
Pretty good.
Well started.
I've got one person started. Anyone else?
I talked to Peter about it this morning.
Oh, okay. That's good. What did he say?
We were just talking about testing.
Testing. Oh, okay.
Oh. What did you say? He's done.
Yeah. Okay. All right. Peter's done. Oh, okay. All right. Well, that's all for today.